So we've come to this point in the Solidity beginner series where we need to cover arrays. They are pretty simple if you have any prior programming experience. You're going to grasp them very easily. So there are a couple of differences if I, let's say, compare them to the JavaScript arrays. For example, the first difference is in the Solidity arrays, or I should probably mention what arrays are in the first place for the beginners out there. So they can store multiple items and not only one, like we did with variables. And you can store multiple items like strings. This can be names of football players, as I did here. You can store, let's say, scores of them. This can be an integer array. And this is my first point about arrays. You cannot store items that are of different type in the array. This is different from the JavaScript arrays. And this is the first difference in the Solidity arrays. You can only store items of one type, so they should all be the same type. I'm going to talk in this video, I didn't give an introduction, but we're going to see the difference between fixed and dynamic size arrays. And we also have storage arrays and memory arrays, which are pretty different because in Solidity, as I've talked in the previous videos, you have storage and memory. You can store data in these two storages sort of in Solidity. So let's go ahead and zoom in and I'll show you the syntax for the Solidity array. So first, the only difference is when declaring variables, you should add these parentheses here. This is what tells the compiler that, hey, this is an array instead of a string. If we remove these, this is going to basically be a string. And this is how you would initialize a value. Again, you would use the same brackets. And inside you would just add your items separated with comma. And since this is a string array, you would only have strings in here. And let's come to this fixed versus dynamic size array thing. So this is a dynamic array. Here in the brackets, how do I know this? Well, in the brackets there isn't any number. So if you want this to be a fixed array, you'd have to add a number here. So let's say 3 because I have 3 items here. So this will be a dynamic sized array, and with dynamic sized array it means that this is of dynamic size, so which means you can add more, or you can append items, you can add more items in the array with this push method. This is a method that you get on any dynamic sized array. And also this is a storage type of array because, as you can see, it is defined at the contract level, which means this is Solidity is going to try to save this in storage. And let's see what functions I have here. So I have add an update element function. This is going to push an element. So we have 3 football players here, Messi, Ronaldo and Neymar, and I'm pushing, or I'm adding Robert, and then I'm accessing, I didn't mention this, but each element is presented with an index, and if you want to access Ronaldo, for example, you'd have to put in 1 here. So access the array first, and then in these brackets you provide the index, and then you get the actual value associated with that index. So this is how you would add an element to dynamic sized array, and this is how you would update one. Then we're going to delete. I have a delete an element function. This is going to reset the value to its default value. And how it's not going to delete actually. There's no actual deletion. You just use the delete keyword. In Solidity, each variable or each type, actually doesn't matter the type. Each type actually has a default value. For string, it's just an empty string, like this one. If I delete this is the string default value. For integers, 0 is the default value, etc. So here we're going to just reset the value to an empty string. We're not going to delete anything. This is how you would define memory arrays. These are stored in memory, and you can only define them in functions and not on the contract level, because even if you try Solidity, the compiler is going to yell at you. So their syntax is a little bit more verbose. So this, you have to provide the memory keyword in here. Again, you have these brackets, and you have to say new int these brackets and add curly brackets, and inside of them you need to provide how much size does the array have. And we would add elements to the same way that we added in the storage size array. And this is how you would, if you want to, just I'm here telling you the syntax for returning an array. You'd have to again return keyword and provide the type, the brackets, because you want to tell the compiler this is an actual array, and then provide the memory keyword. This is going to say, hey, this is going to be stored in memory, do not try to store this on the blockchain. So let's deploy this contract. If I go in here into contracts, I'm just going to save this first and wait for this to compile, and then I can click on deploy. Make sure your arrays contract is selected here. Then I have my contract. This is my football players array that I have defined here. This is public, and now to access, for example, the first element, you would have to put in an index here, like 0. Click on the array, and we get Messi here. If I put in 2, I'm going to get Neymar. Let's call the add an update function. This function is going to push Robert and change the Messi item, update its value to the new Messi. The transaction was completed, so now if I see my element at the 0th index, it's going to be new Messi, and Neymar was index 2, and now we have added Robert and at index 3. So if I check the value at index 3 and I wait for the transaction to be completed, I'm going to see Robert at the 3rd index. So let's go ahead and call the delete an element function. This is going to delete or reset, more specifically reset the value to its default value at the index 2, which is Neymar. So let's click delete item. The transaction has finished. Now if I go ahead check the item at 0 at 2nd index, I don't get anything.